Hello class. Let's continue with another model on ammeter. Here we are talking about the MCQs on ammeter. Here is the first MCQ for you all. If only 1% of the total current is to be passed through a galvanometer of resistance G, then the resistance of the shunt will be what? All the options here you can see are given in the form of G, like G by 25, G by 45, G by 49 and G by 99. Let's work out with this MCQ class. We know that Ig by I here is 1%, that's 1 over 100. Now, but we also know that N, which is the conversion factor, is I over Ig. That's just the reciprocal of the given data. So it becomes 100. Now, as we know, S is given as G over N minus 1, and N here is 100, and G here is G, as there is no value given. Options also require G. So let's plug in N as 100, and I'll get as G over 100 minus 1, that's G over 99 ohm. And that's my answer to the first MCQ, which is option number D, class. I hope the MCQ was pretty easy to be solved. The next MCQ, class. When a current of 1 ampere is passing through a galvanometer coil, the coil is deflected by 20 degree. But when it is shunted by a resistance of 12 ohm, the same current produces a deflection of 5 degree. The resistance of the galvanometer is what? All the options here in the form of ohm. Let's solve the question, class. Now we know that from the principle of MCG that I is proportional to theta. So can I write Ig by I as theta 1 by theta 2? So my theta 1 here, when it is shunted, is 5 degree, and when it was not shunted, it was 20 degree. So it's 5 by 20, that's 1 over 4. But I know that Ig by I is also 1 by N, that's my conversion factor N. So basically I get N as 4. Remember that, class. We want the resistance of the galvanometer, that's G. I have a relation of S and G with N, that's S is equal to G over N minus 1. I have N as 4. I have the shunt as 12. I just need to solve for G, class. So solving for G by cross multiplying S and N minus 1. Let's plug in S and N. And on plug in, I get G as 12 into 3, which is 36 ohm. And that's my answer to the MCQ, which is option number B, class. The last MCQ in the model is there's an ammeter consisting of a galvanometer of resistance 45 ohm shunted with a resistance of 3 ohm. If the current rating of the galvanometer is 500 milliampere, then the maximum current that can be measured by the ammeter will be what? So we need to find the maximum current measured by the ammeter. Now we know that Ig by I is S over S by G. Now we want the maximum current that can be recorded, that's I. It can be written as Ig into S plus G over S. I have Ig, I have S, I have G. So I have all the things required for my formula to be solved. So let's plug in the values. Ig as 500 milliampere is basically half ampere, that's 0.5. S is 3, the shunt resistance. The galvanometer resistance is 45, so it's 3 plus 45 over 3. And on solving this, I'll get I as 8 ampere. And that's my option number D, and that's my answer to the MCQ, class. Thank you.